Hello, everyone, and welcome to today's episode of Sadlier School Live. My name is Camberly Woods, and I am pleased to be introducing you to Dr. Christopher Brunell. Thank you for being here with us today, Christopher.
Thanks, Cam. It's a great pleasure to be here. It's kind of I feel in awe. I get to follow Matthew in this spot. He's been such a great joy to watch and people are responding to him. It's thanks for thinking of me, and I'm hoping that I can carry on the tradition.
Oh, I'm sure you can. And we love Dr. Matthew Bayronavand. And if you guys are interested in watching any of his previous episodes, you can watch them here on Facebook. And I will link to a few of those episodes while we are chatting today. So I want to start by doing a little introduction about you, Christopher, since you are new around here. So here it goes. Christopher Brunell is a former American high school mathematics teacher of 14 years. That might be a little bit different now. Undergraduate professor of mathematics turned mathematics education professor. He is passionate about helping people see mathematics as a human endeavor, not something fraught with merely fearsome processes to be memorized. He maintains that being better at mathematics will make you generally more joyful and successful while assisting you in your aims to flourish. He is an ambassador to the Global Math Project and a member of that organization's executive advisory committee, while his day job is that of professor of math and STEM education at Fresno Pacific University in Central California. He is available for doing other speaking engagements and professional development too. So if you want to get in contact with him, I know that he's going to be sharing that here on today's live. And I will also be linking to some of your accounts in the chat as we're chatting today. So Christopher, let's talk about today's topic, which is very intriguing to me because it is why learn math at all?
Thanks, Camberly. I appreciate it. Please feel free to call me Chris. Christopher is my official title-y name. It's what my mother called me when I was in deep trouble. So,
well, I'm glad we can move beyond the formalities and just get down to.
Okay, I appreciate that very much. I feel better if it's just it's Chris and Cam having a conversation.
Perfect. Let's do it.
Anyway, yeah. The question has come up so many times, mathematics, what's it good for? Why do we learn it at all? Why should we, as a society, force our children to go through 13 years of this instruction? Because it's the one subject next to reading and other language skills that we force kids into for their whole educational life. So
yeah, and it's something that you hear a lot of students as well ask, like, when am I going to use this in my future? How is this going to even translate into my job someday? Like, I don't get why I have to know this.
Right. There's all of those applications, and there's all these other audacious claims. I mean, you read my bio, and in there I make some pretty outlandish claims that knowing math will make you a more joyful person. It'll make you a more successful person in whatever endeavor you choose. I still hold to that. I'm pretty confident I could argue that claim with just about anybody. Do you want to? Can we get started on maybe the start of an answer?
Yeah, let's go ahead. Do you want to share your PowerPoint and we can start walking through it?
Yeah, let me get there and share. And whoops. We'll start from the beginning if that's all right, not the end.
Perfect.
Okay, so yes, this is me. You can get hold of me at cbrownlmath on Twitter. That's the simplest way. Cam, you can feel free to give my email address out to folks as well.
Okay.
That's fine. So do we learn math so that we can regurgitate facts on demand? Is that why we take students through learning things like the multiplication table. Do we really need for everyone to be really solid and know that 9 times 9 is 81 and 9 times 7 is 63? And why do we stop at the 12s? Why don't we ask students to go to the 20s or the 200s or the 1733s? No, we don't necessarily believe that these facts are the critical issue. There's something about knowing some of them that's helpful, and there's something deeper. And some of that is illustrated by the fact that often we write multiplication facts in a table, something like this, a method of organization. And that method of organization is also carried on in other areas of mathematics and in other areas of study itself. That other table at the bottom has nothing to do with multiplication facts of integers. It has something completely other, and it's important to people who study the idea of rotations and other sorts of transformations in the plane. That's something that 8th graders talk about in public schools, and this is a way to get at it. No, I think there really are two main reasons for studying mathematics, and one is the general joy of knowing, and nothing in mathematics, nothing in the world, I think, communicates confidence in knowing more than actually doing math and doing it well.
Chris, I'm going to interrupt you really quick. Will you move forward in your presentation to this slide?
To which slide?
To the slide on these 2 points that you're talking about right now.
Aren't I there?
I'm still seeing the first slide.
How is that the case?
I think if you click.
Oh, it's been paused for some reason.
Yeah, let's try it again.
I apologize.
Don't worry about it.
So did you?
I don't think I saw it. Yeah, here we go. There is your tables that we were just talking to.
Oh, and I didn't get, so you weren't seeing those while I was talking about them?
I didn't see them.
Oh man. Now the whole thing is lost.
Not at all.
Okay, so I just want to point out then about that this table, right, the table of multiplication facts, that's something you've seen, everybody is familiar with. But this other table below it is not necessarily something you've seen. It looks a little different, and but it's organized in a similar fashion. And
yep.
that organization idea is more important, I think, than the fact idea. And
I get it, what you're saying, because if we look at the top, we're going to see in the upper left-hand corner 1, 1, and 1, where in the bottom graph we see E's. The letter E is represented there in place of a 1. So the pattern is the same.
Very keen observation on your part there. You are looking for something I'd like to talk more about, and that is this idea of looking at patterns. But that's the main topic, so we'll get there. Let's see. How can I? Okay, did that show up?
Yep, we're good.
Okay, we're back in business. So, as I was saying, there's two reasons, I think. Joy of knowledge, but equally important, and this is probably something that schools are more concerned with, is the developing of strong habits of mind. By habits of mind, I choose that phrase on purpose. It follows after some researchers in the late 90s and curriculum writers, Al Cuoco and Greenberg and Mark, three researchers whose first names I don't all remember, but they put together this list of ideas that they turned into an organizational framework for all of the organizing principle for all of their curriculum. And they were there. They make these statements that really kind of intrigue me. The idea that generations of students have learned something that we call mathematics, but isn't really the mathematics that people who practice math or create math or apply mathematics outside of school actually do. So what is it that we can get at? Is it important that they know specific results, or is it better that they learn the habits of mind used by the people who make mathematics? And I would argue that that is a much more important reason for knowing and doing and learning math.
I agree.
So
It's like a deeper understanding of what it is that you're learning, because you can work into, you know, problems different ways, or anyways, we can.
yeah, right, exactly. And
Mhm.
so I'd like to start. As often as I am, as you'll have me back, I'd like to talk through some of the habits of mind that they identified, and also kind of give some reasons for why they include them and examples of what these habits of mind are. So first is the idea that students should be pattern sniffers. So, Cam, I know we talked a little bit about this earlier, but here is a pattern. The first pattern across the top are the counting numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yep.
And then below that is a row I have labeled squares.
Yep.
Are there patterns you see that you could describe?
Okay, so one pattern I noticed when we look at the squares is that the numbers alternate between odd and even. So we have 1, which is an odd, 4, which is an even, 9 is an odd, and so on. So that's one pattern that sticks out to me.
Very interesting. Do you think there's that pattern continues?
Yes, I think so.
Yeah, you think so? Could you come up with, could we, with some discussion, come up with ways to make our feeling about that a little more than a feeling?
Yep, like more of a concrete answer.
Yeah, I think there's a way to do that, don't you?
Yeah, probably.
Sure.
Let's walk through it.
Well, yeah. So let's think about it a little bit. How does this one? Where did this one come from?
So that one is the square of 1. So it
That's the,
came from the number 1.
right. So one is the square of one. What do you know about this one? Is it even or is it odd?
It is odd.
That one is also odd. Yeah, very good. And so I have an odd one that generates an odd square. What about this square? You said this square would be even, yes?
Yeah, so the even number 2 is creating an even square of 4.
Very good. Now, I think, no. Anyway, so you've got an even 2 that's giving you an even square. And what about 3 and 9?
Yeah, so 3, here we have an odd number, which is creating an odd square of 9.
So at this point, are you feeling like you could even more carefully phrase what pattern you saw?
Yeah, so I would say that when the root number is an odd and we get the square of that root, the answer is going to be odd. If the root number is 2 and we get the square of that, then the outcome is going to be even.
Very good. So I think when you said 2, I think you meant even. Is that correct?
That's what I meant. Sorry.
I thought so. I know you're nervous being on camera for the first time. Okay, so it looks to me and sounds to me like you've seen that odd counting numbers generate odd squares, and even counting numbers generate even squares. And that's a that's an idea that can be extended with algebra. We could create an algebraic representation of what it means to be an odd number and an even number, and look at their squares and genuinely prove what you have just said, which means we could know for a fact that what you've just conjectured is true. And in mathematics, and in all the world of learning and thinking and doing, mathematics and mathematicians are the only scientists who actually get to claim proof, which I find fascinating. All the other scientists are giving great ideas and theories, not necessarily proofs. Um, when I was looking at this the first time, one of the first patterns, another pattern I saw is similar to these numbers. Do you see what I see?
Yeah, so it looks like this row you've pulled up here, we are looking at the ending number. So for example, the ending number in 16, if we go down below, the square of 16 is 6. The ending number of 25 is 5. 36 is 6. So if we look at that green line by itself, where you've pulled out those ending numbers, we can see that the pattern repeats itself because it's the same at the beginning and then it repeats itself at the end with the 1, 4, 9, 6, 5, 6, 9, 4, 1, 0.
So it kind of climbs up and down, huh? Doesn't it? Yep. What do you think? And here's one of the beauties of sniffing patterns is it also allows you to think about the future. What would be the next last digit in if I were to?
One is going to be a 1, maybe, right?
Yeah, it kind of feels like it would be a 1. Can you verify that, knowing what you know about multiplication tables? What's the next?
Yep, 11 times 11. So we're looking for the square of 11, and that would be 121.
So it ends in 1. So it looks like we start over. And then coming after that is 12 by 12. Just to check, let me think. 12 times 12 is 100 and 730. No, wait, it's 144, right?
Yep.
Okay, so that ends with a 4. So it looks like we go back to the 1, 4, 9,
6, 5, 6, 9, 4, 1, 0.
I happen to know that 13 squared is 169 and 14 squared is 196. How interesting. My real question about that is, I mean, there's loads of questions that come out of sniffing just at that little pattern. One question I have is, why aren't there any 3s? Or 8s? Or 7s? How come these are, that's just something discriminatory going on there, I think. Anyway.
Yeah. I think it's interesting here because you're pointing out the things that are maybe even missing from the patterns, the things we don't even see in the pattern. And let's talk about why those are missing from this.
Yeah. We could, and now we're talking about playing. Now we have these numbers, we have these patterns, and these patterns beget the more patterns. They get us thinking along other lines. And this is what I think of as playful mathematics. You're not just playing games with math. You're actually playing math games with the things that you're doing, and you're gaining strength and facility with the numbers themselves, and your influency over the counting numbers and their squares, and now even something to do with evens and odds and their place value, all sorts of things come into play here that we can explore. And parents can explore these with their kids, and teachers can explore these with their children and their students. Um, I know we're running a little close on time. Should I go with one more, or what are your thoughts here?
One more pattern?
Yeah.
No, let's skip the pattern and let's go on to kind of like your summary of stuff and why this is important.
Okay, so I'm going to skip this, but if you want, we can come back to it another day. So I'd like to just reiterate the idea that, and because this is the first time you've had me on, I just to round out sort of my introduction. I am a math teacher. I taught math at the high school level for 14 years, and then for the last 20 years at the university level. I am really convinced that anyone can learn mathematics. I'm also convinced that possessing these habits of mind will make you better at anything and everything that you choose to do. And learning may be hard, but joy is not diminished through difficulty. In fact, often the joy of discovery comes after much labor. And I'm convinced, genuinely convinced, that a mathematical mind is a playful mind. It is a wonderful playground that you can take with you everywhere you go. So I'd like to spend as much time as we have together, you and I, Cam, and explore more ideas along those lines, if that's all right with you.
I love it. And I think that you are spot on in saying that if we can foster these mathematical mindsets, it helps us, nurture problem solving in students.
Yes.
And this resiliency, right? That there isn't really a wrong way to do anything. There's multiple ways to do things right. And so, it's always interesting to learn about others' way of solving problems, because we learn of other people's ways to solve problems. We might recognize different patterns and different ideas that foster creativity later down the road.
Yes.
So I love it. And I loved doing this exercise with you. It's one that I know I'm going to take and use with my own children at home, because it's simple and it opens up a math discourse where we can just have some discussions about it and get fun thinking through these different, what is in this pattern, what's missing from this pattern, why do you think it's odd or even? And
very good. Yeah, those are all critical questions whenever you're sniffing out patterns. What do you see? What don't you see? Why do you see only what you do get to see? What are the, whenever you do stuff like that, you're looking at root causes, and those are important things to grapple with and wrestle with.
I love
fun.
It. I love fun. They are fun. And it makes math feel creative. It feels creative and it feels like a game. So I think when you can layer those two elements, it does make it more fun and more playful. So thank you again for being here with us. We will be back tomorrow at 3:00 p.m. Eastern, 12 o'clock Pacific. And I can't wait to talk more math with you, Chris.
Thanks, Cam. I look forward to it.
Bye. Talk to you soon.
Bye.